variable so we don't get any errors. So then the next thing we want to do is add an if statement, which is going to be if our te variable isn't equal to null, then add our squiggly brackets, and then we simply want to type label 10 colon and then we want to make a for loop, which is going to have an integer of x which is equal to 0, and then if our x variable is smaller than our tal entity new furnace variable called te dot, come on, oh yeah, because we haven't made that class, sorry, dot get size inventory, then our I variable is to go up. So basically this for loop is saying if the integer of x, which is equal to 0, so we're making a new integer called x and then semicolon, if that x variable is smaller than the tal entity dot get size inventory, which we will make later, which is going to be 3, then I is to go up. So basically this method will run 3 times, and each time our each time our x variable will go up, so it'll go 0, 1, 2. So then within this we want to make a new item stack variable, and we are just going to call this item stack, and we're going to make that equal to our tal entity dot get stack in slots. Then within this we're going to pass our x variable. So basically this new item stack is equal to our tal entity dot get this stack in the slot of 0. So basically every time this method runs, it's going to be 0, 1 or 2, which is going to return this item stack variable to either 0, 1 or 2 slots. And as there's 3 slots in a furnace, then this will return our stack depending on which time it's run, if that makes sense. It's kind of hard to explain really. So then we're going to make an if statement, which is if our item stack is equal to null, so equals null, then we are going to continue with this statement. So float, we're going to make a new float variable called f, which is equal to our, what do we call a random variable? Our random variable, which we called rand dot next float times 0.8f plus 0.1f, then end that variable. So basically our float called f is equal to a random float variable times by 0.8f plus 0.1f. Then we can just copy and paste this 3 times and rename it 1 and 2. So now we have 3 float variables, and then you want to type the Java term do and then add brackets to that. And what we're going to do is if item stack dot stack size is smaller than or equal to 0, then so basically if our item stack in any of the slots is smaller than or equal to 0, then continue label 0, and this should have been label 0, sorry, not label 10. So basically, if our item.stackSize is smaller than or equal to 0, then it is going to go back up here and do this all again. So it keeps repeating itself basically. Then below this we want a new integer called, what are we going to call it, y, which is equal to random.next int 21 plus 10. So we're making a new variable which is an integer called y, and that is equal to a random integer between 0 and 21 plus 10. So a random integer between 11 and 31 is what we are adding here. And then if our y variable is bigger than the item stack dot stack size, then y and then our y variable is equal to the item stack dot stack size. Yeah. Then we're going to do item stack dot stack size minus equals y. Right, so basically if our variable between 11 and 31 is bigger than the stack size, then that variable equals the stack size, then our stack size is going to be minused by the stack size basically, so it depletes it completely. Then we're going to make a new variable which is an instance of the entity item class, and we're going to call it EI, and it's going to be equal to a new entity item, and within this we are going to plop in our world variable, and then we're going to make a float variable which is going to be I add f. Right, so basically what this is saying is our I variable, which is the position, the x position, is going to be added to the f position, which is our random float variable. So basically what this means is once this entity enters the world, it will spawn in our I position added to a random integer, so it will fly out at different angles, is basically what this is trying to do. So we can then copy and paste this twice, and for the second one we want j and f1, and for the third one we want k and f2. And then the next variable is going to be our item stack, so we want new item stack, which is going to be our item stack variable that we made up here, dot item ID, comma space item stack dot get damage, dot get item damage. And we've got a whole lot of errors. World float item stack. Oh, sorry. Take out this, and it wants to be comma space y comma space item stack dot get item damage. So within our item stack, we want our item stack, which we defined up here, the item ID, so the ID of the item, then our Y variable, which is the stack size, then the damage in case it uses metadata. So then the next thing we're going to do after this is if our item stack dot has tag compound, then entity item dot EI, so our entity item variable dot item dot set tag compound NBB tag, NBTT compound item stack dot get tag compound dot copy. So basically what this is saying is if our item stack has a tag compound, which is a tag compound is the saving system, so when you quit the game it will save what is in your inventory, etc. So what it's saying that our entity item dot set tag compound, so it's going to set the tag compound of this entity item that we just spawned in the world to be the item stack that we are using dot get tag compound dot copy. So basically it is giving our dropped item a tag compound if it needs one, if it already has one. Then below that we're going to make a new float called F3, which is equal to 0.05f, and then entity item, I keep doing that, EI, so our entity item variable dot motion x equals float rand dot next Gaussian times our F3 variable. So the motion x is going to be a random double times F3, which is going to be passed to a float integer. So this will basically send our item flying off in different directions again. Then this middle one wants to be plus 0.2f, like so. Then below that we want world dot spawn entity in world EI. So basically after sending it off in different directions, it is finally going to spawn it in the world so it can fly off in them directions. And then below this we want to type while true. Then down here, just above here, so here, we want super dot on block removal world ijk. So basically this just runs the onBlock removal method that we are overwriting after it's done all of this. And that is it for our block test furnace class. As you can see, we do have some errors because we haven't created all our classes yet, but we can go ahead and save that, and then we will be heading into the next class, which is going to be, we're going to make the tile entity class next. Right, so what we want to do is when my Eclipse sees